About a year ago, we did a video on space gene. We talked about the two astronauts, Scott Kelly and Mark Kelly, and how they are identical twins. And Scott Kelly went up to space for a year while his brother Mark stayed on Earth. And what they did is they took tons of different samples while Scott was in space and Mark was on Earth to try and see if there were changes happening because of space.
This is the perfect control, being able to do this with an identical twin, because the baseline genetics are identical.
Yeah, so it's a super cool study, and recently they published the results from this study. I think it took about probably 2 years for them to analyze all the data, because while Scott was up there, he was taking poop samples, probably urine samples, blood samples, probably saliva too, a lot of different samples. So it took a while, and they've had a lot of researchers involved in this work, because they wanted to look at physiological changes happening to your telomeres, transcript changes, epigenome changes,
metabolism,
proteins, immune, metabolic,
all the omics,
heart, yeah, so many different things. So it's taken a while for them to analyze the data, but they published it.
That's fair, I'll allow it.
Yeah. From the study last year, the big headline that we covered was that it said, oh, Scott Kelly is 7% different from his brother Mark.
Which we know can't be right, because we're all 99.999% similar.
NASA had a blip in their headline, and it should have been, they had 7% gene expression changes, which is still really interesting and pretty big. And that was just resulting from space.
And most of the genes that changed were involved in, like, muscle, right?
A lot of muscle. I think some involved in probably the eye too, because I know the eye suffers a lot. The reason why they did this study is they have no idea what long-term spaceflight will do to humans. And since we're trying to get to Mars, I think they said it would take probably 3 years round trip to do the Mars trip, and you don't want to send astronauts up there and then have them have these like horrible body failures,
right?
Where there's no one to help them, like in The Martian.
I actually read a book called Rise of the Leviathan, and they had a very interesting interpretation of what would happen if humans like grew up in space.
What did they say?
There were these people that lived in the asteroid belts, they called them the belters, and they had like elongated necks because there was no gravity to like pull them down.
NASA has done some previous studies like looking at astronauts and trying to see, okay, what changes are happening from the 3 month, 6 month, and year trips that people have been on before. And what has been known is that muscle and bone change a lot due to gravity. If you think about it, gravity is a force that's being enacted on our muscles, so our muscles are almost responding to that all the time. And when you're in space, you lose that force, and so your muscles lose some of their tone, they atrophy a little bit, and you're just not as strong because you haven't had to be dealing with gravity. And similarly with bone, you see bone loss as well because of gravity as well. And then they also saw changes in your eyes, and a lot of that's due to just the radiation that's present in space, and some of that like degrading like part of your retina. And they have like a specific name for this one kind of ocular issue that they see in astronauts, and most of them suffer from that.
Interesting. So it's from the radiation and not like being in artificial light all the time.
I think it is more from the radiation. So in the most recent study of the twin study, which is what they called it, I don't like that. In the study they recently published, they analyzed all this data and also had data from Mark and Scott about a year after Scott got back to Earth, because they wanted to see, are these changes persisting over time, or are they eventually going away since he's not going to still be in space?
That'd be really interesting to know if there's like a point of no return for some of these.
Yeah. And I think with most of them, what they saw is that most things changed to be back to normal. So last year you may have heard of, the telomere lengths are longer, and telomeres are kind of a measure of almost age. The longer telomeres you have, the more likely you'll live longer. So they said, his telomeres are lengthening, like maybe space is the key to a longer life. And then I think within a day he got back, they shortened. Which is insane when you think about it. Like how can that happen so quickly? But
how quickly did they lengthen?
I think it was consistent, because they mentioned for some other things that some things would change in the first 6 months, whereas other things would change in the last 6.
Right.
But for telomere, I think it was consistent.
It just was gradually.
Mm-hmm.
Okay.
Yeah. Another thing they saw that kind of returned to normal was gene regulation, because they saw a lot of those gene changes that resulted in the study from last year and what they said. They also kind of saw that your gut composition went back to normal, probably because you're eating.
Yeah, that has to be diet-based.
Yeah. Yeah, I mean, your microbes, a lot of that's dependent on what you eat.
So do they make... Who stayed on Earth, Mark?
Mark stayed on Earth.
Do they make Mark eat space food?
That would have been a good control, actually. He probably would have not been down.
Yeah.
Go to Christmas party, can't eat any eggnog or Christmas cookies. Eat freeze-dried ice cream.
Oh, God. And it'd be fun for a day, but...
Yeah. And they also saw that retinal thickness went back to normal. But I think Mark still does have some other eye issues because of that. I think one of the most interesting things they found in this study was, I mean, we talk a lot about epigenetics and just how there are changes that happen kind of above DNA so they can be reversible. And they didn't see a ton of epigenetic changes happen in the first 6 months that he was up in space. But during months 6 to 12, they saw a lot of epigenetic changes. So it's basically saying, like, he's gotten used to his environment, and now his environment is affecting his genetics and what genes are expressed or turned on or off. And a lot of these changes actually stayed persistent in his genome, and that's probably led to a lot of the gene expression changes he's seen.
The epigenetic changes or the mutations?
The epigenetic changes persisted. So some interesting things they looked at, I mean, since they looked at him both before and after he came back to Earth, they saw that actually coming back to Earth was a pretty stressful took a stressful toll on his body. And they saw some changes in immune response gene networks, and that some of these weren't responding the way they should, and also cognitive performance. And they saw cognitive performance kind of start to go down from 6 to 12 months, and it's still down in Scott.
Jeez.
So they thought that's a really interesting finding, because if your astronauts are having to make these really important decisions, what if their cognitive performance is down and they're not able to function at optimal level?
Yeah, especially if they're making multiple launches. Huh. Have they ever... it would be interesting to look short term, but just not on twins, to see if they also have these cognitive changes.
Yeah, and I don't know if they've really done much of that before, but I feel like now they're definitely going to consider that, because that's pretty huge.
Yeah.
So the changes that they saw persistence in, or that they've continued like over the time that Scott has been back to Earth, they saw changes in gene expression, which is likely due to epigenetics and just that regulation. Also DNA damage due to chromosomal inversions, which this is just a fancy way of saying that there are mutations that likely resulted from the radiation of space. And those things are not reversible and can sometimes be passed on to your children, but depends on if it's just in your somatic cells or in the cells you're going to pass on to your children. They, interestingly, in space, the telomeres got longer, but once he came back to Earth, his telomeres got shorter, and they said that was due to stress, and just probably the stress of going up and coming back.
Man,
and
stress is dangerous.
I know, it is.
Jeez.
Gotta stop being stressed. So it'll be interesting to see. I don't know how long they're going to continue monitoring him to see if maybe they'll get longer the longer he's here. But I think now he's retired from doing space stuff, so he's probably not going back up.
Is Scott going back up?
No, I don't think so. I think he's retired now. And I think Mark had retired a while ago. So they've both done quite a few space missions.
Yeah. Oh, they're both astronauts. I did not remember this detail.
Yeah. So they
That
actually
could
were
also like skew.
Yeah,
I mean, we're only looking at 2 people here, and if both of them are astronauts, it would be interesting to do this study with more astronauts and more like people that have never been up to space.
Yeah, because maybe he's been adapted a little bit more.
Primed.
Yeah. They interestingly, I think they both were in the Navy and were like war captains, so they have some similar experiences in their life, which is like pretty cool.
Yeah.
Another thing they saw that persisted was just ocular issues, and that's again just kind of due to the light and radiation in space, and then the cognitive function going down. So, and I think, that's definitely the thing they're most concerned about. But I think the conclusions from the study is that most things return to normal, and flight for longer than a year should be safe for humans.
Yeah.
And I don't know if they're going to start trying to increase that amount of time before they send people up to Mars for 3 years. But at least it's a good baseline to say, okay, we kind of know what should change and how to prepare. Like with the muscle and bone loss, I think they have the astronauts do different exercises on the flight and just really try and keep your muscles engaged.
What about the ocular changes too? I feel like there would be easy ways to protect the eye too.
Yeah, I didn't read anything.
Special sunglasses.
Yeah, I feel like that they could probably definitely make those too. But as always, this was a study only done with 2 people, so it was more, they've always said it was to generate hypotheses and to kind of open up the next set of studies that they can do. It's never been like, oh, this is always going to happen,
right,
since it's only 2 people. But it's still super interesting because it is twins, and as Rachel said, it's the perfect control. Or maybe not so perfect. That's what you think about it, but it's close.